Okay, guys, so far we have looked at solving quadratic equations by factoring and then by completing the square, and then you were reintroduced to the quadratic formula by Mr. Eves as he converted the standard form of a quadratic function into the quadratic formula. So recall, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to start today by looking at this equation, 6x squared minus 7x minus 20 equals 0. And we're going to solve this two different ways. The first way we're going to do it is we're going to solve it by factoring by grouping. So remember, this is the first way we looked at solving, is by simply factoring. And in this case, because the a is not 1, then we need to do it by grouping. So we can start by using our x, and we know that a has 6 and c has negative 20. When we multiply that, gives us negative 120. Our b is negative 7. So our factors are going to be negative 15 and 8. So we can input those, and we get 6x squared minus 15x plus 8x minus 20 equals 0. And so we're going to group them like this. And so I'm going to factor out a 3x, which is going to leave us with 2x minus 5. And if I factor out a, 4, that's going to again leave us with 2x minus 5. So that leaves us 3x plus 4 times the common factor of 2x minus 5, still equal to 0. We're going to set both of these equal to 0. So subtract the 4, gives us 3x equals negative 4, divide by 3, gives us x equals negative 4/3. And then we have 2x minus 5 equal to 0. That's 2x equals 5, divide both sides by 2, gives us 5/2. So there are two solutions for x. So now we're going to solve this same equation, but now we're going to use the quadratic formula. So we have our quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So when we look at this equation, we see that our a equals 6, our b equals negative 7, and our c equals negative 20. And now it's just a matter of plugging that in. So we're going to start with a negative 7 plus or minus the square root of negative 7 squared minus 4 times 6 times negative 20 all over 2 times a, which is 6. So now we can simplify this down and we work out our numbers. So this is going to be 7 plus or minus the square root of 49, and then a negative 4 times 6 times negative 20 is going to give us a positive 480 all over 12. So we can continue to simplify this down. That's the square root of 529, still all over 12. Which equals 7 plus or minus the square root of 429 is 23, all over 12. So now we have two possible solutions here. We have 7 plus 23 divided by 12, which equals 30 divided by 12, which equals 5/2. And we have 7 minus 23, all over 12, which equals negative 16/12, which equals negative 4/3. So you can see, either way we solve, we get the same answers for this particular equation. So that's what should happen when we do this. When no matter what method we use to solve these equations, we should end up with the same answer. So let's take a look at another example. So let's look at 3x squared minus 4x minus 9 equals 0. So again, we have our a equals 3, our b equals -4, and our c equals -9. So we're just going to plug these numbers right into our quadratic formula. So we have a -4 plus or minus the square root of -4 squared minus 4 times a, which is 3, times c, which is -9, all over 2 times a, which is 3. So again, we're going to simplify this down. So that's going to give us 4 plus or minus the square root of 16 plus -4 times -9 times 3 is 108 all over 6. So we can continue to simplify this down. That's going to give us 4 plus or minus the square root of 124 all over 6. Now 124 is not a perfect square, so we have to figure out something here, and we have to break this down. So we can break this down by saying, okay, 124, if we do 2 gives us 64, or 62. 2 gives us 31. And so since we have a pair of 2's, we know that we can pull out a 2 here. So that's going to be 2 times the square root of 31. So we can write this out now, and we have 4 plus or minus 2 times the square root of 31 all over 6. Now we can reduce this by 2 because each of the factors in here have a greatest common factor of 2. So we take 2 out of the 4, that leaves us with 2. Plus or minus, that 2 is going to be removed, gives us 31. And 2 from that is 3. So our two solutions are going to be 2 plus the square root of 31 divided by 3, and 2 minus the square root of 31 divided by 3. And we can leave our answers just like that in that form. So here's another example now. So this one is going to be a little different. This is going to incorporate now the imaginary numbers and complex numbers that we were working on previously. So we have x squared minus 9x plus 27 equals 0. So again, I'm going to set up a equals 1, b equals -9, c equals 27. And now we're just going to plug this right into the quadratic formula. So we have negative b, that's a -9, plus or minus the square root of b squared, that's -9 squared, minus 4 times a, which is 1, times c, which is 27, all over 2 times a, which is 1. So that gives us 9 plus or minus the square root of 81 minus -4 times 1 times 27, that's 108, all divided by 2. So now here we have 9 plus or minus the square root of -27. So now we have a square root of a negative, which remember we need to break down and have our imaginary number come in here. So and this all remains divided by 2. So when we have the -27, that's going to become the square root of -1, which we know is I. And now 27 we can break down. So 27 is 3 times 9, and 9 is 3 times 3. So we have a pair of 3's here. So that means that we're going to be able to pull out a 3, and we can rewrite this whole thing now as 9 plus or minus the square root of 9 is 3, the square root of -1 is I, and that leaves us with a square root of 3. And that all still remains divided by 2. So we have two solutions here. We have 9 plus 3 times I times the square root of 3 divided by 2. And we have 9 minus 3I times the square root of 3, all divided by 2. Okay, so one last practice problem. So now we're looking at 4x squared plus 12x plus 9 equals 0. So again, here we have our A equals 4, our B equals 12, and our C equals 9. So I'm going to plug this in. So we have negative B, so that's now going to be a negative 12, plus or minus the square root of B squared, minus 4 times A, which is 4, times C, which is 9, all over 2 times 4. So we can simplify all this. That leaves us with negative 12 plus or minus the square root of 144 minus 144 all over 8. So that we can simplify as the square root of 0, which we know is 0. So that's going to leave us with negative 12 plus or minus the square root, or plus or minus 0, all divided by 8, which equals negative 12 divided by 8. Which reduces to, 4 goes into 12, 3, a negative 3 halves. So we have just one solution here. So whenever you're given a quadratic equation, you can plug in the A, the B, and the C into the quadratic formula, and it's going to give you an answer. One of the characteristics of all of this is that we have to look at the discriminant. And the discriminant of a quadratic equation, when it's in standard form, so when it's in ax squared plus bx plus c, is the value of that b squared minus 4ac. So that number can be one of three things. It can be positive, which means it's greater than 0. And in that case, there's going to be two real root solutions. So looking back at what we've done, when we had that root and it was positive, so the first example that we did, here, b squared minus 4ac is greater than 0, and we ended up with two real solutions. The same thing here. In this case, b squared minus 4ac was positive, so as a result, we ended up with two real solutions. 2 plus the square root of 31 divided by 3, and 2 minus the square root of 31 divided by 3. On the other hand, if b squared minus 4ac is equal to 0, then we end up with one real root. We end up with one answer. And that's the last equation that we did. Because this equals 0, we end up with one real root answer. However, if we end up with b squared minus 4ac being less than 0, so we end up with a square root of a negative number, then we're going to end up with two non-real roots. We're going to end up with two imaginary number solutions, or two complex number solutions. We are not going to end up with a real root solution. So that is this example that we did here. Because we end up with b squared minus 4ac being negative, we end up with two answers that we have this imaginary number. This is a complex answer solutions. These are non-real root solutions. So as we're looking at these equations, we can immediately look at an equation, 15x squared minus 3x minus 42 equals 0. We can look at this and we can say, okay, we're going to take b squared and plug into b squared minus 4ac. So in this case, we're going to have negative 3 squared, which is 9, minus 4 times 15 times negative 42. So in this case, that's going to be a negative 60 times a negative 42. So this is going to end up being a positive number. So because it's a positive number, we know we're going to have two real root answers. Now, on the other hand, what if this was plus 42? Then when we plug this in, we'd end up with 9 minus 4 times a, which is 15, times a positive 42. Well, in this case, we know that negative 4 times 15 times 42 is going to be a negative number. So as a result, we know that there's going to be two complex root numbers. So from the very beginning, before we do any real math, we're able to determine looking at the discriminant. So remember, you need to remember this word. Discriminant. This is a key term for the quadratic formula. You have to look at the discriminant, which the value for the discriminant is taken from b squared minus 4ac. And depending on if that is greater than, less than, or equal to 0, that's going to tell you how many answers and what type of answers you have to this equation. So we'll talk about this more, and you're going to see some practice problems on this in the group work tomorrow in class. Have a good night, everybody.